Okay, so now that we have our delineation, I'd like to show you how to estimate CN number based on land cover. So first what I'm going to do is turn on the aerial background and sort of zoom in and look at what this land cover looks like. So it looks like we've got a mostly residential area, we've got some streets here, so this is relatively simple. But in order to estimate CN, you need not only land cover, but you also need an estimate of the soils. And to use that, we're going to use the hydrologic soils group shapefile that was included in your map package. And what we're essentially going to do is take this subcatchment that we delineated, we're going to export it into a new shapefile, and then divide it up into land cover classifications, also broken down by soil types, or hydrologic soil groups. So I'm going to take this subcatchments layer, I'm going to export it, all entities is fine. This is my example model. This is going to be land cover underscore post. Okay, and so now if we unlock that layer, we can restructure it and add all the, take out some of these attributes. We don't need all of these attributes that were for the subcatchment, so we're simply going to delete all of these out. I don't know a faster way of doing this, unfortunately, not within this software anyway. So delete those out, and I'm going to add a couple more. So one I'm going to add is an attribute, and I'm going to call it CN, and it is going to be an integer, and it will be input manually. And then I'm going to add a category for HSG, which is hydrologic soil group. Oops. And attribute HSG, that's a text. It only needs to be 4 wide, maybe 5. Save that. Still. Okay. So now, if we look at the table for this, this has these values. And so what we can do is go inside the map and we can divide these up. Now first, the way I'm going to do this is I'm going to divide it into land cover class, and then I'm going to look at where those land cover classes intersect different hydrologic soil groups. For this subcatchment, it's actually fairly easy. I'm going to click the edit, and I'm going to do the split function. So first I need to select it, edit, I'm going to split, and then I'll zoom into the subcatchment here, maybe, and sort of split along the road, because really this subcatchment is going to have two land cover classes, one being residential and one being for the street. So I'm simply going to click all the way around, sort of estimate where this road is. And I hit enter when I'm done, and click split, and now it has split this into two groups. So now I've got, so I'm going to call this is my residential, We'll make an estimation of what kind of acres that is. And then this is the road, street. Okay, so now with that I can split this street section into, click and go up here and click split, and then I'll do the same thing down here. Select this, click split, and now what I can do is use this to set the HSG. So that's type A, and this is type A, or B rather. Okay, so we divided that up, so now we can select this other area and assign this a land cover. And like I said, there's going to be two classifications in here. This classification, this land cover, is going to be a residential. And in order to use the CN table that's provided in the TR55 method manual, that's what we'll be using. In order to use this for residential land cover, we need to look at and get an idea of what size lots in order to use this percent impervious and the CN number. So we'll go back to the model and we'll get a sense of that. In order to do that, I'm going to zoom in really quickly here and just use the ruler tool. I'm going to set it up to measure polygons, and I'm just going to go here and approximately look at a couple of these lots. So that looks like almost call it 0.25 acres. Take another sample over here. You know, if we move this maybe about halfway, yeah, about 1/3 acre lot. If we do this over here, escape, try it again, go about halfway. So about 1/4 acre, I would say we're probably right around a 1/3 acre lot if we average these out. Yeah, it looks like about a 1/3 acre lot is what I'll call it. So we'll go here and we will divide this up based on the soil types, but we know that the land cover is going to be residential underscore 1/3 acre. So it's a 1/3 acre lot, residential, and if we turn on the soil map, we can divide this up using the split tool again, and we'll just kind of zoom in here a little bit. Doesn't have to be exact. And just split this along approximately the vertices of that shape. And split. So now we've got that as B for the hydrologic soils. It's B. This is A, and that is A. And streets B, and streets A. Perfect. So we've got that set up. Now with this information, I can use this table to choose the parameters So for instance, this residential 30-acre lot, we're going to use the values from this table, and we're going to say that those are approximately 30% impervious area. And for B soils, they have a 72 CN number. So I'm going to go back to the model. So it's 30 and 72. So we'll go back to the model. That is 72. And I just realized I need to add another column. So to do that, I'm going to save this. And I'm going to go to restructure. I'm going to add an attribute. I'm going to call this imperv percent. So, alright, and we'll give this a number. Well, we can just do integer. And we'll save that. So now that is 30. So now I can set that. So for A, same land cover, 30-acre residential, but hydrologic soil group A. So that says 57 there for the CN number, and the percent impervious does not change. So we'll set that. It's 30 and 57. So for the streets land cover type, I mean the percent impervious is 100 and the CN is set at 98. We can see that in the table here for streets. And it doesn't matter if it's paved with curb and gutters, you assume it's 98. Paved with open ditches, including the right-of-way, so that's 89. And that's actually more what we have in this scenario. So we actually are going to use this paved with open ditches, including right-of-way. So that for the A is 83, and the B is 89. So 83. And down here, say 89. And this is a conservative estimate on the percent impervious, since we are saying there are some ditches in the right-of-way here on this half the road. So that is it. Now we have a land cover classification for our developed condition, and with this data set we can go to our subcatchment and use the PC Swim area weighting tool to, so data source would be the land cover post, and the destination layer would be the subcatchments. And then we go to next, and it brings up this table right here. And so here we say, what are the values in the destination layer do we want to area weight, compute area weighted averages for? And for this example, we're going to use the curve number from the land cover post, and then we're also going to use the percent impervious. So now we've chosen the two attributes from the data source layer and selected where they're going to be going into in the destination layer. Click calculate. It gives us a summary of what was done. So the old percent impervious was this, the new percent impervious is this, the old CN number didn't have one, the new CN is calculated here. you can copy this information. So you can copy this and paste it into a text document if you want. And then if we check out the subcatchment, turn off that, click on the subcatchment, we can see that those parameters are in fact computed for us and parameterized in our subcatchment.